Hello, and welcome to this Building Domain Session 2 as part of the buildingSMART International Summit, Marrakesh 2024. Thank you for joining. My name is Andre, and I will be your moderator today. Today's session is titled Fire Safety Occupant Movement Analysis. The speaker for the session is Peter Thompson, Senior Research Engineer at the University of Canterbury. This session is scheduled to last 90 minutes, including time for questions at the end. This session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speaker, I would like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendees here in the room, please keep background noise to a minimum, and if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now, I would like to hand over to Peter.
Thanks. So those that made it, great. Hopefully there's some online as well. I'm not going to talk for 90 minutes. You'll be relieved to know. Maybe 40, 45. If you've got a burning question, feel free to ask at the time, but there will be some discussion at the end as well. So first of all, this project I'm presenting, I'm from the University of Canterbury. I'm a research engineer and I've been involved in software development for many years. I used to work at Autodesk as well. And Peter Lawrence and Asim Siddiqui, between the three of us, we make up the main three people doing, I guess, the core technical work on the project. They're from the University of Greenwich and the Fire Safety Engineering Group. So first of all, background of the project, just to recap on some of our motivations. The Occupant Movement Analysis Information Delivery Specification. I'll be covering the four various stages of that development, what it delivered, some of the challenges and some of the achievements as well. And then also covering the Fire Safety Engineering IDS and its current status as well, because they're sibling projects. And also the future and what's next. So first of all, the key motivational driver for the project is, amongst many other things, Grenfell Tower fire was a good example of failures of a multiple case of different things going wrong. One of them was a lack of maintenance of information and poor design. One of the things highlighted in the report from Judith Hackett was the golden thread of information was required. It's a phrase you've probably heard many times, but she also recommended that it was used in BIM as well, and a BIM approach within the UK and high-risk developments too. One of the motivations. Another, for example, other examples around the world of various different losses of data in buildings, particularly fire safety engineering. The new Berlin airport is probably one of the best examples of a failure of communication of different disciplines, particularly fire safety aspects, and it is 10 years late as a result of a lack of coordination on that project. And as a result of various examples of this kinds of bad management of data, coordination, etc., in buildings for fire safety, a group got together of industrial partners and organizations called the International Fire Safety Standards Coalition. They came up with a decade of action to try and change fire safety as a global sector, to bring it up to speed. And that new framework called for audits, compliance checks, and global standards, and some level of harmonization. Fire safety engineering as a profession is a fair way behind other professions in terms of adopting BIM as an integral part of the workflows generally. So we started with the initial project scope of covering everything from fire, smoke, various calculations, simulations, evacuation, egress, circulation, regulatory compliance checks, a lot of things all to do with fire safety and occupant movement. After various discussions, we split that up into two areas: occupant movement analysis and fire safety engineering, because the occupant movement analysis side of things covers a broad range of areas outside fire safety as well. And a number of people on the group weren't fire safety engineers. And the idea was that we could make sure that we could cover both areas and include aspects of circulation and other aspects along the way as well. So the idea was that the occupant movement analysis isn't restricted just to fire safety engineering, but covers circulation, optimal flow at railway stations, for example, that kind of thing. And the IDS project started first with a large working group across the world. When I started, I was based in the UK. I've since moved to New Zealand. And everybody listed there has contributed in some way during the course of the project, different countries, different continents, and it's been very useful getting a whole set of field of views from architects to engineers, etc. Project overview, it was basically divided into two phases, which is the standard way of developing a new IDS now. Phase one, to produce process maps of the workflows and processes. We sat down with fire safety engineers and architects to work out the workflow they went through, and then produce some initial data requirements to achieve that workflow as well. Phase two was to review those data requirements, extend them, and then to also review the IFC 4.3 schema to see what data was already included, and then list the extra stuff which we wanted to add on top to achieve those workflows for occupant movement analysis. And then to produce an IDS which listed both the things we want in the existing 4x3 and then also added on top to extend it to meet all of our needs. And then once we got the IDS, to create a model and test it with the IDS and then produce the final report. Basically to create the whole specification, test it out and make sure it validates too. This rather large diagram starts off schematically describing the whole workflow we want to do on a design iteration for a building. So up here, number one, create the model. Number two, export the model to an IFC format. And number three, take your IDS and check that that model has all the data in it. Now, those three steps are really the ones you need to do when you're creating an IDS file for buildingSMART. You're creating a new standard, a new set of data. It's those three stages you need to cover in the project. We wanted to take it all the way through a design iteration and also then ultimately take the data, take it out, check the IFC file has all the right numbers in it, bring it into a pedestrian modeling tool, run some simulations, express those results, maybe try and use a BCF file to feed back to the design, take that design, export it, add that to the IFC file format, and then ultimately bring it along at the end for an authority to review the design. So we wanted to test the whole loop, not just the one required for the standard development. And the development work itself, well, we covered a number of aspects and different software tools along the way. I'm not going to list every single tool, but we broke down the different things we use tools for. Model creation, our main tool was Revit. IFC editing, sometimes we did, I guess, by hand with Notepad++. Others we used IFC viewing tools like BIM Vision, and then the accreditation of the IDS file, the editing rather, we used Notepad++. The validation, we used the BSI auditing tool. And then later on, a really useful tool was BlenderBIM, which takes your IFC file, takes your IDS, and systematically goes through all the way through checking that your IFC file complies and gives you a really nice, rich report of passes and or failures. And then also the BCF testing, we use BIMCollab as well. We used a number of other tools along the way, and I'll get to that in a minute. But we did test lots of different tools out in this pathway. Multiple tools we used, primarily because when we used different tools, we were also using the latest standards. So we were trying to use IFC 4x3, we were trying to use IDS 1.0, BCF. So all of those latest standards weren't supported by all the tools, and that we only really discovered that by using them. Some of them said they did, but they didn't cover everything, and that created problems for us. Ultimately, even if they said they supported IFC 4x3, for example, we found there were still gaps sometimes, and that still created us problems. But ultimately, we did manage to bring the whole workflow through, and we were also limited by some of the availability and cost of tools. All three of us are at universities, there's a limited budget, so we couldn't take the risk on expensive purchasing of software on the guess that it would fully work, because we want to test it ourselves. So only the places where we could test the software fully did we trust it, and ultimately we came up with some tools which did. So we showed that diagram of all the steps that we took the whole project through. First of all, step one, create the model. We started off with the model from Revit 2022, which was developed by Nazim Yaku for a master's project which I supervised. And he built an add-in and also a nice hotel model. We took that through. I added every element that we could possibly think of to test the whole schema. So we put some moving walkways outside the building, which you wouldn't normally see, but we also added a lift inside, an escalator inside, signs, alarms, every aspect which you would want to see to test out the new standard. In that process, for example, we picked a double door. Then we start to look at the individual data points to add in required for all the occupant movement analysis tools. So having gone through the workflow analysis, we identified the core parameters in each of these elements that were required. And you can see there, the green ones are the ones that were already in IFC 4x3 specification, but we know that we needed them. And then the ones with this kind of peach background, they're the extra ones that we added in this project. So direction of travel is an indicator of which way people are going to go in case of an evacuation. It's like a default direction of travel. The effective width, which is a measure of the space in between door jambs for people to walk through. And then the design people flow rate, which specifies your caps on flows for doorways. I mean, most standards around the world use 80 people per meter per minute, but there is some variation in that, especially when there's demographics. If you've got a high mix of elderly or mobility impaired people, then you will see a drop in flow rate. So that's just the first example of some of the extra things that we added in as part of the project for the schema. Similarly, spaces. So for this is shown a lobby area here. And in green, you can see we're going to need to know the number of people in the spaces, whether or not that space can be used for a fire exit is important, especially for zoning. The normal usage area per occupant, and that peak value we took to mean the fire safety loading, essentially, which is the general description in the specs. Whether or not it's accessible for handicapped people. They're all really useful points in the schema, but then also we added in the design people flow rate again, for caps for design, and then the nominal width and nominal length, which are also used for some of the flow models as well. Yeah.
what you're doing if you don't have a rectangular space
Oh, so
with a normal length and height is
yeah, so that's why it's called nominal length and nominal width. It's a approximation of that space, and the reason it exists as a nominal width and a nominal length is that some of the movement models only look at flow, so they don't really model the complexity of the space. That's when they need those kind of nominal, analytical measurements, if you like. Yeah, so it's kind of conjuring up an equivalent rectangular space if one existed to do that modeling on. Yeah. Okay. Next example was an escalator. So we added the escalator to the hotel model, and we had a few parameters in green which were useful, but then also a whole bunch of things which were only in the staircase before, but we needed to know for our advanced simulation tools that we could model these things, especially things like the loading area, to model people queuing to get onto the escalator, that kind of thing. And then probably the most challenging one to bring in was lifts, because we know that we needed a lot more data for lifts, especially because in the fire safety evacuation rules world, after Grenfell and other incidents, there's a big move to start to use elevators for evacuation purposes. So we looked at that quite closely. There were some useful parameters already for capacity of people, clear width and clear depth. But then we put in some more information about the lift dynamics, the acceleration rates, the door opening times, the jerk rate, which is that little start and the end of the movement of a lift, and the stories served, etc., etc. All the core data required for you to be able to accurately model that lift. But that's only an expression of the lift mechanism itself. What we need to know is also how people move into the building, enter the lift, come back out of the lift upstairs. So we need to know the pathways related to the lift, which creates a problem because it's no longer, like most of the things in the IFC schema, it's not just an individual block of things with parameters. We need to understand how it relates to other spaces. So there are some ways of doing that within the IFC schema. And I don't know if you can read that, but there's 3 different types of zoning that you can specify in IFC files. The IFC zone, which is probably the older established one, which is a collection of spaces and other objects, generally a generic one, but it does have a object type of lift shaft, elevator shaft, sorry. There's a spatial zone, which was more recently added, which has a predefined type of transport, and there's also a built system, which has a predefined type transport. All 3 of those can be used to combine spaces and elements in a single group system. Spatial zone didn't work because it was primarily intended on one level, I believe. The built system, in some ways, on principle, probably is the best one to use, but it's so new we couldn't get anything to work with it at this stage. The built system was only introduced, I think, this year, and some of the lift designs we saw used the building system in IFC4, but that was deprecated and replaced with built system. So we chose IFC zone simply because we could make it work. So we used the IFC zone in the project. And actually, one last thing. What you probably should see here is within the zone, we've got space, 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 space. Connected space boundaries. It includes the lift car as well. All the things we need to know for that system. And the tiny little bit up here is just a little screenshot noting that for a general zone, you can have a predefined type elevator shaft, which is what we're using to queue everything from. Some screenshots now of how we actually implemented that as a control system. So we've got, this is BIM Vision, I think. Zone Within that zone, we got the spaces. And we cut the lift shaft into 4 spaces at 4 different levels, primarily because after we just had it as one space, we found that Revit wouldn't export any of the doors above the bottom level. So we had to split the space up into 4, and then Revit did finally export the doors above the different levels. Next up, looking at the connections again. Here we've got within that zone 4 spaces, and space 1.28 contains the elevator car in all its exact definition. And then breaking that hierarchy down so you can actually read it. Well, we've got the 4 space and lift shaft, and ultimately this is how we track everything through. So the 4 spaces, this one here, of all the spaces in this initial state, was assigned the lift car, the transport element, and that space, for example, also has a level 2 space boundary assigned in the IFC schema, which creates connections. That space boundary includes the door, and on the other side we have the corridor on that level, which also includes a space boundary and a door, which obviously connects the 2 through. So through that series of a zoning, breaking down the spaces, a space with a lift car, and then the space boundaries, we create this whole spatially connected system, which we can finally model a staircase, and ultimately the evacuation of people through the building, through that pathway. And that gives us the definition of basically where people can come in and where people can go out as well. Next step was to export the model to the IFC file after the fairly complex process to get everything set up with the different zoning and the control systems. So standard Revit export process on the main screen. We did use IFC 4x3 because we needed the latest standards. And we also exported the second level space boundaries to get those connections for the lift control system. The other thing we did in this export process was we leveraged every single aspect of manually defining the data in Revit. So in Revit, you can use schedules to export property sets if they're not covered by the other export mechanisms. You can use custom defined property sets for different areas on known objects. And you can also use a parameter mapping table as well to rename things on the way through. Ultimately, we had to use all 3 of those different things if we were going to manually edit these things in the model, really because we set ourselves the tasks of not trying to rely on a coded tool bespoke to Revit, but just manually enhancing the BIM file and making sure we can get all these things out to be totally transparent. And ultimately, then we had to create the IDS file based on that list of requirements. So we had our list of parameters and all the different levels. And then we used Notepad++, very basic tool, to create the full IDS file, listing element by element all of those parameters that we want listed in the IFC file. And the buildingSMART technical team did give us a hand there because we were new to the whole process. And ultimately, we developed the IDS 1.0 format file and tested it against the IFC 4x3 file as well. And finally, in that first groups of steps 1, 2, and 3, we created the IDS, and then we validated it, checked it with the online validation tool for IDS files from BSI, and got it to pass. So we made sure that our IDS file was valid and compliant. And then finally, we used BlenderBIM to iteratively go through. Here we've got, you can't read it on the screen, but in BlenderBIM, you just specify your IFC file, your IDS file, and you run the comparison. And it's just basically a dictionary lookup. It iteratively steps through your whole BIM file, checking all the data's there. And in this case, it was missing some of the core data points. And it does a really nice job of listing where the failures are and what they are, so you can go back into the file and fix it. Ultimately, in the model that we generated, we created objects of all the types we needed, and all the data ultimately got to pass by filling in all the data points, and produces a nice long HTML report which validates everything for you. So, in that 10-step design loop, that was our first 3. I'm not going to spend so long on the other ones, but it's just to take you through the whole journey. So finally, taking it through a mock process, which you might ultimately take to get it into a fire authority for review. Well, down here you see, we run the simulation tool, export the results, bring them back in, check the IDS file against the IFC file, check the results are there, and ultimately, hopefully, the authorities are going to review it at that stage. So we had 2 options here: simple extraction of the project, looking at the basic elements and properties, slabs, stairs, doors, and walls. That basic geometric processing approach had some advantages. It always used standard data types. All the data was there. But it doesn't really reflect the connectivity that we need to know for people coming in and going out of the building and defining all the routes. So we used the space boundaries, originally designed for thermal heat transfer, but also happens to give us the connections between elements in a building. So we use the level 2 IFC rel space boundary elements, and that gives us the connections, which spaces connect to which doors connect to which spaces, to allow us to define routes. It does give us more granular information about the spatial connections, but it's not exported by default in Revit. You have to manually click it on, and occasionally it misses things which the user hasn't specified in the project either. So the model has to be well defined. Step 4, data extraction, looking at the options and the process. So the basic data extraction here, one option was to write the functions directly into the pedestrian modeling tool. So in this case, buildingExodus, which is the modeling tool for the fire safety, the research group at Greenwich. The other option was to generate a separate intermediate tool, entirely standalone, to do all the data processing of the IFC and convert it into the right file format. And we chose option 2 simply because it was more flexible, and also it was expandable as well. So we took that translation tool and also expanded it for another evacuation model tool as well, called evacuations. So down here you see a sample command prompt. Basically, we just ran these Python scripts, which enables us to look at the visualization of the data and the elements, and also bring the whole translated set of data into buildingExodus in this case, or also for the flow model evacuations. And it does a pretty good job at doing that translation process. Step 5, then in buildingExodus, set up and run the simulations. So in the simulation tool, you have to define your population, specify the scenarios, whether it's evacuation, egress, ingress, that kind of thing, and then run the simulations and produce the results. Some of the screenshots here. So here you go in, specify the mixture of demographics, so male and female, and other aspects which would affect walking speed, that kind of thing, and they would potentially affect flow rate as well, and the ability to escape. Run the simulations. And then once you've run the simulations, you then need to share the results. So that's when we started using the BIM collaboration format files, which is intended for communication within the teams. The original communication was for issue tracking. So we're kind of using it for a slightly unusual case here because we're trying to express results, but it was the most appropriate file format available for us. And then our focus was really to communicate those results to stakeholders in general. And you might see the figure there, RSET, required safe egress time, which is in fire safety engineering a key number. It's essentially looking at how long people take to get out of the building. And it's your benchmark result. You compare that against the fire simulation tool, which is the available time before the space becomes toxic. So you're just trying to get those key numbers out which evaluate safety in the building. We use different tools, and ultimately there were some limitations that we encountered with the BCF file format, primarily because it was originally designed as a issue tracking tool with fairly small notes and all kind of packets of data going around the design team. We wanted to associate it with larger sets of results. We wanted to know the flow rates through the doorways, for example, over time, and the performance of the building. And the BCF file doesn't really support either large sets of data or even particular fields for cross-referencing the data either. So the final solution we came up to with after talking to Mirbeck was adding in a reference to an external file just in the description notes. Far from ideal, it just about worked, but we're hoping this format's going to get updated. Just going through the last few steps here, we added the results back into the model, so we checked the results. We want to bring in headline results back into the model as well. So at a high level, packets of IFC information. We added in the pedestrian model tool version, the simulation time, simulation results summary as a result. And then down here, we're looking at these core data points, adding things at a detailed level as well. We want to know things like maybe every 10 seconds, the number of people going through every door, so we can really understand the danger areas in buildings and where things are going to become unsafe as well. But this is just stored at a custom property set we created, occupant movement analysis, simulation results, stamped in at the headline level. Then we export those to the IFC file format, checking. You can create an expanded IDS file, check the analytical results are in there, and then also look at the, well, really checking that both the input and output data are included. Ultimately, ideally storing that in the IFC file. And the reason we want to bring the whole thing back into the IFC file is for traceability in terms of regulations and life safety, because if you've got a project and a file, 2-3 years later, somebody wants to go back and check it, you need to be able to make sure that you've got all the data required to run those simulations again and get the same results, to make sure that nobody made a mistake. So we use the data from the IDS check. We've expanded the list here to include some scenario results from the simulations, and also basically some kind of stamps as to which simulation tool we used. We're just labeling the author, the tools, some of the core results. And you can expand your IDS file to make sure that those extra data points are also in the lookup table on your IFC file. So we're really pushing the IFC format and some of those file formats that are available past their limits, but within the boundaries of what's possible, to create this whole proper design loop iteration and pass on to the authorities later. And again, we used Notepad++ for most of those manual edits. And during the later stages here, we are just checking that the IDS is valid. Yep, so our expanded IDS file is valid. And then using that IDS again to check to see if our fully tested model has not only the input data, but also the output data as well. So in this Blender BIM report, it says, yep, the model tool developer is stamped in the IFC file. The contact person who did the simulation, the overall simulation results summary, simulation scenario results are all available as well. And then lastly, trying to mimic a full real world loop. Our ideal hope is that working with the regulatory bodies doing the review process, you have your IFC file and your expanded IDS. And ultimately that helps inform discussions, reviewing the designs. During those discussions, you might get some failures. After those discussions, hopefully the design is modified, and after the simulations, it will pass. But by using these expanded IFC files and the IDS file in the process we've described, that's really the pathway to creating a transparent system where everything is inspectable and repeatable by the authorities and maybe an auditing company as well. So we are pretty much at the end of the project. It's pretty mature. The key deliverables along the way that we've generated are: in phase 1, the process maps, where we went through the whole design phase process, identifying all the parameters that the practitioners needed. We also went through and created an industry insight report highlighting the need for this work and why it was important. And then we produced data requirements, which helped inform all of those extra parameters that we talked about. And that was at the end of phase 1, start of phase 2. As that developed, then we generated these IDS files, and which is nearly complete now, the final project report listing everything that we've done, the issues we encountered, and the end user guidance, which is how to use it and how to apply it. And we've also included notes on taking it past just that 1, 2, 3 step process, but also further on down the line as well. So the report is just about ready to submit. We're just updating some of the pictures and figures at the moment. It will be submitted shortly to the technical committee, and hopefully be ratified soon. Really to help other people along the same pathway of the experience that we went through, some challenges and lessons learned on this project. So first of all, key challenges. Well, we did encounter a range of model and export issues from Revit, because we pushed Revit export right to its limits with all the different data sets on all the different components. And we've documented that and how to manage to make it work using the various features in Revit. And also, one of the things we came across was the lack of support for lists in data. So there is a IFC property list value, which in theory would support adding results in, etc., etc. But there's very little support for it in most of the tools available. And that was a bit of an issue for us. We had to use comma-separated lists in text strings to get these things through. IDS 1.0 is quite new and had limited support, again, in some of the tools. The BCF file is limited for, it's intended for issue tracking. We tried to use it for file referencing because we wanted to reference big detailed results files. It's not built for that. We know that in our simulation set, we might have big JSON or HDF5 for very large simulation results. BCF doesn't even allow for the explicit cross-referencing to the file as well. So we're going to push for at least adding that into the file format. And then again, we had the same issue with different file versions not being supported properly either. So some of the key lessons learned in that process. Well, enforcing the latest versions of the different schemas that we chose to do, IFC 4x3, IDS 1.0, etc., amplified some of the data issues. We did overcome them, but we had to manually edit some files in some places to complete that whole loop. buildingSMART International worked examples are very useful, and we would like to see some for some of these more challenging scenarios like lifts, for example. There's 3 different ways of doing it with the features available. Having some kind of recommendation about doing it a particular way would have been good. The way we came up with works. I think in the longer term, when there's more support for the IFC built system, that's probably the better way to go. But it would be good to have that documented. And then also, buildingSMART data dictionary support is great. We would like to get the occupant movement analysis data points into that data dictionary soon, as soon as this is ratified, really. So achievements over the project overall, the working group and expert review panel. In addition to geometry in buildings and the basic geometry, which kind of goes without saying, we identified an additional 96 key properties to be added into the dictionary, or at least identified existing ones which were key to this workflow. We called on a range of architects, engineers, academics, all of whom gave up their time willingly. So a big thanks to everybody that helped. And the core technical team, myself, Asim, Peter, spent a long time on this. A lot of this is in-kind effort. Also Jarno in the LAB in Finland helped as well. Thanks to him, and Peter and Asim as well. So buildingSMART International also helped us. So a big thanks to Richard, John, Leon, Merbeck, the Building Domain Subcommittee, the technical team, who recognized that along the way we came across various technical issues because we were pushing the boundaries at different stages. Ultimately, they all helped us, and we came through it. Finally, next steps in the project. Well, occupant movement analysis is on the brink of submission. Then it'll be reviewed and hopefully published and then added into the IFC schema. Fire safety engineering, which is the project we started off with right at the start, has been, the work for that has been started. The proposal has been accepted by the Building Domain Subcommittee, and we're waiting the final go-ahead. But we already have a PhD student working on it, and we'll be creating a detailed project plan soon. Also, occupant movement analysis in infrastructure is something which Peter and Asim have been discussing with some of the folks at buildingSMART as a next logical step on, because you really need to consider, for example, large crowds outside sports stadia. That can create some very complex flows, trains moving around externally, everything from music festivals to large events outside, which have some additional data requirements, but are controlled by the built environment. So that's a future project, which is under early discussion as well. And we already have a team of people who have started looking at the fire safety engineering aspects on this next project. So spread across the world again, involving software engineers, Pathfinder, for example, John Utstrand from Cowie, Manuel Kitzlinger, Johannes in Australia, Rihang in New South Wales, and also Jarno and Timo up in LAB, myself, and then obviously we've got Chan, Asim, Peter, and John in University of Greenwich, and Mike Spearpoint of OFR Consultants. And OFR have sponsored the PhD student, and together that's where the core technical work is going to be started for the fire safety engineering work. We've got just enough money to fund the PhD student, but if anybody would like to either help or fund or co-fund in any way, any amount, that would enable a bit more of outreach on that project as well, to reach a bit further, maybe for conference travel, etc., etc. But the project is going ahead. We could just use a bit more cash to help to reach out, communicate, expand the network, etc. And that's it. So it was a summary of the main bulk of all the occupant movement analysis work for the new standard, and also a little note about the fire safety engineering work as well. The idea was to have a few minutes at the end for a bit of discussion, and maybe if anybody wants to talk about our approach to the lift zoning or our issue with the BCF files or any other questions. So, yeah.
Yes, thank you very much for a kind of a detailed presentation of what I've been having. Yeah, first of all, I'm not a fire expert, but you have prescriptive rules and you have functional based rules, and kind of you look at the functional based. I suppose that you should get out of the building before you have too much smoke. There's a project in Denmark and Netherlands and Belgium trying to look into this prescriptive rules. But what about are there any? Can you use any tool you would like, or the different? The prescriptive rules are often national. I heard something about in Sweden you have to calculate the if you have a dead end of something, you have to calculate it twice and so forth. And maybe it's adopted in Denmark, but maybe not in the Netherlands and so forth. So what about how the have you taken into account this, or is the tools that just kind of what the tools require, or how do you have been handling that?
Yeah, you're right. There's a large data set required for some of these analysis, and the prescriptive approach to codes varies country to country, sometimes region to region in different countries. And the dead end calculation you mentioned, that is mentioned in a lot of prescriptive codes, but often with a different distance, depending on whether it's the US or somewhere in Europe, for example. This system doesn't track the calculation line. That's down to the regulatory requirements room, I guess. What it does do is it defines all of the material properties and the spaces in the building to make sure that all the data is there to do those quick calculations afterwards. So it's there to support those calculations. And in addition, it should have all the data there to do a full simulation. So that would be the performance-based regulation analysis. So the calculations for distances or zoning, et cetera, you'll still need a little analytical tool, but the idea here is that all the data is there for the tools to work. And then for the performance-based one, where we're looking at the available safe egress time and the required safe egress time, this should cover all of your core data needs in order to be able to do that full simulation route for an egress calculation. That's the idea.
I have an additional one. It was mentioned yesterday. I think it was the University of Vienna that mentioned something about their doing some bit with escape route analysis, kind of identified, and then wrote it back as IC segments. So you actually have the result of the calculation made as IC elements that could be integrated in the models. Is that something that could be interesting to do in this case also, or?
It could be. There is in Revit itself, there's a travel distance calculation tool, path of travel. I wrote the engine for that. And it is expressed as a polyline, so that could be stored as a full calculation pathway and stored.
Yeah, but I think here they calculate the kind of, could be if you have a tube, whatever kind of, you might not actually pass a corner with 5 centimeter or 0 centimeter of distance, kind of. Maybe you will have half a meter to the corner, kind of. So it was a different way to calculate. So there was put into IC as some segment, not just a line but a volume following a pass. So that could, it sounds like it could be interesting to combine these methods.
Yeah, you combine that. Yeah.
So actually, it's working here, but I guess you hear me anyway. So. Okay. Yeah, so we had a kind of a volume, but we did not really represent the correct or the actual geometry of this cable, of the width. In our IFC representation, then we just had like a tube, but we had single segments with an IFC spatial zone, so that the meaning of the entity is correct. And then we group these segments with IFC group, so we can have different segments in several escape routes, because they come together at specific places and then they merge like this. And we didn't want to duplicate elements, so we grouped these elements with IFC group. But the difference is that we wanted to represent the building code requirements, and I think you do more like a simulation, how people actually move. So this is a difference that's really important to notice.
Yeah, but right, you're right. I mean, for the prescriptive regulations, you absolutely need to be able to define those routes out of the building for sure. Yeah, we haven't actually thought about preserving those as the prescriptive pathways in here, but yeah, actually, it's a great idea. You could use the segments and the lines. Yeah.
If you finish, I would have another question.
Yeah.
Yeah. Thank you. So you said you used an expanded IDS, is that right?
I might have,
I was just wondering what you meant with expanded, or did
yeah, I was just, it was because we're, it was my own term really. So the expanded IDS is really that in those final stages of the design loop, passing on to the authorities, but we took it the extra stage to also add in elements of the outcomes of the simulations into the IFC file, our custom property sets, to express the outcomes in the IFC file for regulatory review, and then check that those data points were in there with well, I called it an expanded IDS file.
Okay, I understand.
Basically to cover the extra data for those simulation routes. Yeah.
Thank you, yes.
Yeah. Peter, Asim, is there anything else that I missed on the replies? Okay, right. Yeah. Anything else? Oh, sorry.
Pete, it's Richard Kelly from buildingSMART. We've never actually met.
First time,
We've
Richard.
worked together about 4 years now.
Yeah. Good to see you.
Lovely to meet you of us. This is just a general comment to the room, actually, is that this project, this initiative is not getting the recognition it deserves yet. And it will, because it's really important. It just hasn't reached the ears of all the right people, because this is going to be super important. I wanted to acknowledge, actually, that this project has really been at the bleeding edge of testing IDS. You put in there that IDS is new. And by the way, Robin Drogemuller, who created IDS, is here, so you can go and blame him. But no, I mean, Robin has obviously, his team done a really good job with IDS. But in the use of it, even people, especially people like me, who are managing the program, I didn't know how to use it either, so I wasn't able to advise you, and we had to work with our technical leadership team. What this has meant is that this project has actually forced the definition of how IDS can be used by the industry, by the domains. So we now have a very clear definition of that. So other projects will not have to go through the same pain this project has been through. Nonetheless, this project has resulted in some really good outcomes, and the people who've been working have been very persevering for a long, long time. I have to say, Pete, all credit to you, because you raised this, you brought this to buildingSMART's attention in the first place. You pushed it. I mean, you were working, in Scotland at the time. It was all pro bono. You've led this program of these two projects. You're now in New Zealand, the other side of the world, and you're still pushing it, and you've come here to present it. So, as I say, it's hugely important. It is going to receive the recognition it deserves, and it will end up being used by industry. And it's tested the buildingSMART processes and enabled us to improve those processes to the benefit of other sectors. So, yeah, well done to
thanks.
you and everybody else.
Thanks, Richard. Yeah, appreciate it.
For me, also, I think it's a really good approach, what I have also done these years with colleagues. And it's not only to give the requirements, and it's really the requirements to modelize, to have the ideas, to make the check. And then you see if you have changed the requirements because you need more information to write the ideas, or how you have to modelize to have also the results. And if you have show also how you have modelized and used the Revit or Archicad or another tool, because every tool has its problem to export or to use details, but the people outside using these tools for this, it's all time also this check to have different tools to check how can I modelize. And I find it really interesting. But you see the use every detail what you are using, I think in the market people outside, it will be really hard to explain and to explain the elements. If we go in the rooms, the boundary, to explain how is this connection, how you have to work, that is working really. And people's outside in a office, when I look in my office, the 100 people, to starting with people who are learning, with experience, old people, young people. You have no time, you have changed a project because one person is missing, and instead you to go in this detail to export this. The software tools, tongue software, is not helping to do this. Really.
Yes.
You need some elements for doing this job for you, so you can thinking on the project and not to thinking about the information management, how I can connect rooms together. And I think this is a challenge to go in this way. But I think it's really interesting to see this, and it's not only thinking what is the requirements of how we can do it to go out and to have this detail. If I need zone, build system or group or what is element, it's not right or false. I think you have to take a decision and to use it. Congratulations.
Oh, thank you. Yeah. Thanks. Yep. Great. Yep. So Peter Asim still online, or are they dropped off? They are. Yeah. So Richard, you can say hi to Peter and Asim as well. Yeah, no problem. So they're the official project leads. I'm kind of coordinator and also technical help. It's essentially been the three of us working on the core together. So.
The relationship with other sectors, so for example, the lifts and the lift zones, we have Schindler, who are part of the membership of buildingSMART, and they're in our product domain. What I'm hoping we will be able to do with them is a project on determining the entities, product entities of lifts, vertical circulation, put those into the buildingSMART dictionary and into IRC. So that's very specific about the actual equipment, if you like. But in terms of the zone, Schindler are also working with other organisations who are doing design of vertical cities, and they're very interested in how people are using buildings, how they're segregating multi-use buildings. When they have apartments in one floor or several floors, and then office buildings in several floors, and retail, etc., etc. So I think this work would also be of interest to that group as well. Now this. I can't say we can go straight to them and say, here we go, this is the solution, because actually they're still learning about open BIM workflows and open information flows altogether. But I do think there is an opportunity there at some point in the future, hopefully near future, to be able to expand this and get it really useful into future living spaces.
Yeah, thanks. There's probably the recommended ways are going to be either zoning or IFC built system eventually. If you want us to chat to them about the approach, that'd be absolutely fine. We might as well coordinate and share that information together with them, because we did put in all the data points to define the full lift dynamics as well. Yeah.
Okay, great. The company that springs to mind that Schindler are working with most on this is Drays and Sommer. I don't know if you know of Drays and Sommer. No, okay, but probably worth getting together.
Happy to chat to them. Yeah. Sounds good. Okay. Great. Any more questions? All good? Right. Thanks a lot, folks. Thanks very much for coming. Cheers.
Well done.
Thanks.
Thank you, Peter. Thank you for attending, and we're looking forward to seeing you at other sessions of the summit.
Right, thank you.